In the next block, I would like to talk about the working principle of the Arteriograph device. Although this method is a result of the original research work between 2001 and 2004, and it has more than 10 years history, still the working principle in some scientific paper is so-called debated. However, it is proven by many, many scientific papers and validation trials. Indeed, to understand the working principle of the arteriograph requires some physics and physiological knowledge, which I would like to share now. The basis of this working principle is the one cuff positioned into the upper arm. How could that be done? This is the aorta, its bifurcation. This is the subclavian artery, and this is the brachial artery, and the cuff is located here. How could we have positive velocity measurement, augmentation measurement with the cuff, which is only one single cuff? The answer is simple. If we can record here the brachial pressure curve at the suprasystolic pressure, a very, very nice situation will develop, namely the first systolic wave and the second systolic wave. This is the first systolic wave to go down to the bifurcation level, and the second systolic wave, its reflection, will be separated nicely, and then this allows us to have and to be able to measure the augmentation index, because if we measure the amplitude of the first and second systolic wave, we can express the augmentation index on the basis of the well-known formula, P2 minus P1 divided by the pulse pressure multiplied with 100. And if we take the time elapses between the first and the second systolic wave, this is the time to go down and to be reflected. Thus, if we can divide this time by 2, we can get one go. And then if we measure the sternal notch pubic bone distance, which is more or less equal to the true aortic length, we can express the positive velocity in meter per second, because the distance is the sternal notch and pubic bone distance, which is called JAC-C distance, and the time, the return time, which is the return time to go back, down and back, and it is the half, return time per 2. So this is the way how we can measure the aortic pulse velocity. This is a very simple way, and it allows us to control the quality of the measurement, to control and to see inside in the device. Indeed, it is very, very important to see whether the measured values are correct or incorrect. So the arteriograph provides in all of the time the separated first and second systolic wave in the screen of the device, in the computer software. Thus, everyone can control whether the measured AIX or aortic pulse velocity was proper or improper regarding the input signal. And this means that the arteriograph system is kind of open system and can be controlled by everybody, and its reliability is guaranteed. Indeed, in 2010, in the Journal of Hypertension, a paper was published about the invasive validation of the arteriograph, and it showed that all of the measured parameters, the AIX, the augmentation index, the aortic pulse velocity, and the central systolic blood pressure were very, very, very highly in accordance with the invasively measured counterparts and the invasively measured values. This means that once arteriograph is used for any kind of clinical work or any kind of trial, we do have invasive validation, and we do have strong evidence that the measured parameters either AIX, PWV or sensile systolic blood pressure is accurate.